We're down to our last two chapters. In chapter 15, we're going to be doing some scheduling problems. Starting with number 16, we're going to work through 16, and then you have a couple of other problems to do that are similar. So we'll work through 16, and then you can do problems 18 and 20 and 22 on your own. They're all going to be scheduling problems, just with varying constraints. Okay, so let's talk about number 16. 16 says that Barb's Beach Bar operates 7 days per week. Barb uses only full-time employees and wants each employee to have 2 consecutive days off each week. So as you're scheduling this and you schedule an employee, they have to have 2 days off in a row each week. And then they work the other 5 days of the week. She believes that she needs a minimum of 3 employees on Monday, Tuesday, Wednesday, Thursday, and Sunday. So those constraints have been put up here in the top. On Friday and Saturday, she believes that she needs 6 employees. Develop a work schedule for Barb. Okay, so what we want to do is there's not a one-size-fits-all on this. You just have to make sure that you're meeting the constraints. So we've got it set up in the template so that when you finish, you should end up with the numbers down here that match the numbers up here. So we're going to I'm going to start off with my schedule by putting off on my first 2 days here, which means that my employee, this first employee, would work every other day. Okay, so that means that I need 2 other employees to work on Monday and Tuesday. Okay, so I'm going to have my next employee work here, and I'm going to give that employee the next 2 days off. Okay, and I'm going to give the next person the next 2 days off. Remember, this is where you're going to focus most of your days off, because on Friday and Saturday you need most of your people to be working. Okay, so if we take a look at our constraints, we've got 3, 3, 3, and 3. So we have at least 3 employees working on the days that she needs them to be working. We've got 6 employees working on Friday, 6 employees working on Saturday, and at least 3 employees working on Sunday. So our schedule meets the constraints that Barb expected in the schedule. So that's what you want to do for 15, 18, 20, and 22. You want to ensure that your schedule is meeting the minimum constraints set up in the problem. Okay, so let's move on to problem number 16. In chapter 16, you start to talk about some project management concepts, specifically managing project planning. The first thing that you learn about project planning is learning about managing project tasks. Here, as we look at this problem, we've got activities A through G in problems 1 and 2. It gives us the activity times for each one of those activities, and it tells us which activity must precede another activity. Now, we did a problem similar to this, if you remember back when we made the dress, and we had specific activities involved with making the dress, and an activity had to be done before another activity could begin. This is very similar to that problem, except now we are going to map this out on a critical path diagram. So what we want to do is use the fill shape tool to identify our critical path. So we've got the diagram already filled in for us. What we want to do is identify the critical path. So the critical path is going to be the path in which the time is the longest to completion. So if we go from A to B, and B to D, and D to F, and F to G, and finish with G, then we want to find out how long that takes us. So 3 plus 4 is 7, 7 plus 5 is 12, 12 plus 3, 15, 16, 17. So that would take us 17, and I believe that this is expressed in weeks. Let's see. We're looking at problems 1 and 2 at the end of the chapter. Yes, these are in weeks. Okay. So that would be 17 weeks to completion. Now let's take a look at our activity time if we go the opposite direction. So we would have 7 if we go from A to B, and then from B to C, that would be 9. 9 and 4 is 13, and then 13 and 2 is 15. Okay, so in order to find the critical path would be the one that took us the longest. So we would want to shade this in using our pink. And I'm just using my little paint tool up here. And our critical path is going to be the one that was the longest path. And this was our 15 weeks and our 17 weeks. Okay. That was it for that problem for 16, 1, and 2. I believe that's all we had to do. Let's see, I think A is asking us for the completion time, which is 17 weeks. And B asked us for the critical path activities, which would be A, B, D, F, and G. Okay. And you're going to do that very similar activity in your other problems. This becomes a little more complicated, but you're still doing very similar activities here. The only thing different here is that instead of being given your times here, you are figuring your times. So we are going to figure them with using the method described in your book. The 2-4-2 method, I believe it's called. Let me give you the page number for that. On page 623. you're going to do your optimistic time plus 4 times your most likely time plus the pessimistic time, and you're going to divide all of that by 6. And that's going to give us our expected time. And we're going to copy that down. And then to get the variance, we are going to calculate the variance, number 6 here. We'll calculate that together. So let's go ahead and get started. And then these up here, we'll also do this one together. I think you have, do you have another one like this? No. Okay, so finding your expected time, we're going to put in an equal sign here. And we're going to do your optimistic time plus 4 times your pessimistic time, or excuse me, your most likely time plus your pessimistic time and we're going to divide all of that by 6. And that's going to automatically fill in all the way down because of the way that the problem is set up. So don't be alarmed when you see all of the numbers automatically fill in. It's just the way that the problem has been set up. Okay, and then we want to fill in your variance. The formula for your variance is on page 629 in your book. And we're going to do it much the same way. It's going to be the pessimistic time minus the optimistic time divided by 6, and we're going to square that. So we're going to be doing the pessimistic time minus the optimistic time, and we're going to divide that by 6. And then we needed to have that all in parentheses, so we need another set on the outside here, because we're going to then raise that so we need a caret and raise it to the 2nd power. And notice that that's also going to automatically fill in all of your values for you as well. Okay, so once you've got all of those filled in, all of your variances filled in, then what we want to do is move on to find out your activity time. So your A time here is going to be the expected time. So we want to put in our values here for our expected time. So this is going to be 6.0. And B is 5.0. And C is 7.3. And D is 7.7. E is 10.2. F is 4.0. G is 5.8. H is 6.5. I is 8.0. j is 3.0. And then you want to find out which of your paths is the longest to figure out your critical path, because you're going to need that in order to move forward, to find out, first of all, the total completion time, and second of all, the critical path. Okay, so you've got